Hello children, welcome back to Insight Engine Academy. We are discussing motion. This is the second chapter in 9th class, right? We have discussed in the last video derivation of the equations of motion. What are the three equations of motion that we have derived in the last class? First equation of motion, V is equal to U plus AT. Second equation of motion, S is equal to UT plus AT square by 2. Third equation of motion is V square minus U square is equal to 2AS. Okay, so these are the three equations of motion, but these three equations can be used only under one condition. What is that condition? Did you remember? Yes, when objects move with uniform acceleration, then only these equations of motion can be used. For example, this is the marker cap, or else it's a marker. I'm going to release this marker. If I release this marker, see, this marker is in my hand. Initially this marker has no velocity, okay, zero, initial velocity 0, okay, but when I release my fingers, what happened? As that marker is going down, its velocity increases, okay, that means it is accelerating due to the gravitational force, that is called acceleration due to gravity. So free falling body also going with uniform acceleration, okay, it falls towards earth with a uniform acceleration. Any free falling body, example of uniform acceleration. Got it? Here we have some problems in the textbook. First we shall solve the problems which are given in the textbook. Okay, after that we will discuss some extra problems also, okay, extra numericals. This is the problem given, example 1 problem in our textbook. So the problem is, a car is moving with the initial velocity 15 meter per second. What is given? Initial velocity is given. So what is the initial velocity of the car? Initial velocity U is equal to 15 meter per second. Car stopped, okay, due to the application of brakes. When car stopped, what will be the final velocity after some time? 0. So the final velocity of the car is 0 because brakes applied, okay. So after 5 seconds brakes applied. What is the time taken to come to rest? So time taken to come to rest is equal to 5 seconds. Find the retardation. So why it is called retardation? Why not acceleration? Acceleration is a increase in the velocity. Deceleration refer decrease in the velocity. Retardation, it is also called retardation. Okay, here is velocity increased or decreased? Decreased, because this object initially which is moving with the 15 meter per second come to rest after 5 seconds. Okay, velocity decreased, so deceleration we have to calculate. What is the formula? Which formula now we have to use among those three equations of motion, that you have to understand. If you are familiar with these solving problems, it is okay, but very new students, okay, who are just learning the equations of motion very first time, whoever while solving the problems very first time, please students, you have to remember one thing. Here what is given? U initial velocity, V final velocity, T time, and they are asking A. So out of these three equations of motion, which equation of motion gives the relation among these four? So where are these four present? These four are present in the first equation of motion. So we have to take that equation of motion. What is that? So to find the acceleration, we have the formula V is equal to U plus AT. But V is given, U is given, T is given, A we have to calculate. Okay, so directly we will substitute the values. After that we can change. Otherwise, after changing the formula also, we can substitute the values. Okay, so V is equal to U plus AT. This can be written as A is equal to V minus U by T. How? So I want A, I have to calculate A. So I write this as U plus AT is equal to V. I have changed LHS into RHS, RHS into LHS. I want to transpose this U from LHS to RHS. Then it will become V minus U. I want only A, I don't want T. I want to transpose this T from LHS to RHS because I want to find only acceleration. Okay, time not required here. Time I have to bring from LHS to RHS. If it is multiplying, time is multiplying acceleration. If you transpose, what happens? Becomes this. So this is the formula. So this kind of changing the terms you should learn. Okay, so this is very very important in physics, because some physics we have formulas, but every time they don't ask the value of final velocity, distance, and this. Okay, they may ask time also. Whenever they ask time, we have to change the formula. Okay, so that is why you have to learn all this. What happen when it is go from LHS to RHS, RHS to LHS, right? Now A is equal to, what is the V value? V value is 0 minus, what is the U value? U value is 15 by T value. T value is 5 seconds. So 0 minus 15. 0 minus 15, how much? 15 minus 15 by 5. Okay. Now A is equal to 5 3s are 15, but plus minus divided by plus is equal to minus. Okay. So minus 3 meter per second square. This is the SI unit of the acceleration. Okay, centimeter per second square, it is a CGS unit. Kilometer per hour square, it is a practical unit. Okay, but here meter per seconds, these are all SI units, so we have to write the units SI. Okay, I hope you understand. So please note down this problem and practice this kind of problems. Okay, here we have another problem. Okay, this is example 2, which is given in the textbook. Okay, so first we shall understand the problem. What is given? A bus is moving with the initial velocity u, u meter per second. After apply the brakes, its retardation is 0.5 meter per second square. After application of brakes, it come to rest. So that is called deceleration. The deceleration value given 0.5 meter per second square. And its speed after 12 seconds. Okay, and it stopped after 12 seconds. Sorry. Okay, due to the light I am unable to read this. This is stopped, not speed. It is stopped after 12 seconds. Right? See, what is the values are given in this initial velocity. We have to find the initial velocity. Okay, initial velocity to be calculated. This will be the question mark first. Okay, and more, what is given? 0.5 meter per second square. What does this refer? That refer deceleration. Even though deceleration is called acceleration, but it's a negative acceleration. That is why we have to write acceleration only, but value should be taken negative, because it is negative acceleration. 0.5 meter per second square. Okay, and it is stopped after 12 seconds. Okay, time taken to come to rest, time t. Okay, here A is equal to minus 0.5, time t is equal to 12 seconds. Okay, so here it is stopped, so final velocity will be 0. Final velocity V will be 0 because it is stopped, right? Right. So here VUAT, these 4 values we have. Okay, so now to find the initial velocity, we are going to use the first equation of motion, because this equation gives a relation among these 4 quantities. Okay, what is the first equation of motion? V is equal to U plus AT. Okay, if you transpose this, if you write LHS is equal to RHS, U plus AT is equal to V. U is equal to, bring this plus AT from LHS to RHS, becomes V minus AT. Okay, now substitute all these values in the equation. U is equal to V value 0 minus A value minus 0.5. This minus is within the formula. A value should be taken negative because it is negative acceleration, into T value. T is equal to 12. Okay, so U is equal to 0 minus into minus plus. Okay, 0.5 can be written as 1 by 2. Okay, half into 12, 6. So U is equal to 6 meters per second. This is the initial velocity. Okay, we found one thing, find the initial velocity. Initial velocity is finished. Next we are going to find the distance traveled by the bus. Yes, we have to calculate. So distance traveled by the bus. To calculate the distance, okay, we have this formula. S is equal to ut plus at square by 2. Of course, we can use third equation of motion also to find the distance. Okay, we can use second equation of motion as well as third equation of motion. Both we will try now. Okay, so see, I have solved the problem after changing the formula. Even though if you don't change the formula also, you will get the value directly. Okay, that means v is equal to u plus at. What is the v value? 0. What is the u value? Should be calculated. Plus what is the a value? Minus 0.5. Okay, into t value 12. So 0 is equal to u, plus into minus minus. This is 1 by 2. 1 by 2 into 12, 6. If you bring this minus 6 from RHS to LHS, becomes plus 6. U is equal to 6 meters per second. Okay, so which is easy for you, whether you substitute the values directly in the equation, direct equation, and will you find the value, or after changing the equation after writing that equation in terms of u, will you substitute the value? It depends on you. Okay, however you get the same answer, there is no issue. Okay, now we are going to find the distance travel. I am going to use this formula. S is equal to ut plus at square by 2. Okay, S is equal to, what is the u value? 6 into what is the t value? 12 plus at square. A, do we have a value? Yes. What is the a value? Minus 0.5. Minus 0.5 into t square. So t square value is 12 square. 12 square by 2. Now S is equal to 6 12s. Okay, 12 6 are 72. Plus into minus minus. Okay, 12 square 144. 0.5 means half. Half into 144 by 2. Okay, now S is equal to 2 ones, 2 into 72. Okay, so 72 minus 72 by 2. 72 by 2 is 36. S is equal to 72 minus 36. Then S is equal to 36 meters. Okay, so in this way we calculate the value. 12 square 144. 0.5 can be written as 1 by 2. This 2 and this 144. One half of the 144, how much? 72. Divided by 2. Okay, I may use this formula also. We shall try with this formula. V square minus u square is equal to 2as. What is the v value? 0 square. What is the u value? 6 square. We got u value 6, right? Is equal to 2 into, what is the a value? Minus 0.5. Minus 0.5 into S should be calculated. S should be calculated. Okay, here this is 5. This is S. Now 0 square is 0, minus 6 square is 36 is equal to 2 into 0.5. 0.5 can be written as 1 by 2 is 2 to cancel. Okay, minus minus cancel. Then S is equal to how much? 36 meters. Do we get same answer or a different answer? We got same answer. So from this, what do you understand? If you have the values, all the values, you can use the second equation of motion to find the distance, as well as third equation of motion also can be used to find the distance. But when time is given, okay, most probably use second equation of motion. If the time is not given, you have to go with the third equation of motion. Okay, it is better, right? So in this way we can solve the problems easily. We can find the distance to travel, we can find the time taken. Okay, all these are real life examples, because to understand, car is moving with a certain velocity, suddenly brakes applied. Okay, immediately it won't come to rest. After application of brakes, it come to rest after 4 seconds. Meanwhile, it travels certain distance. What is that distance traveled by the car? This is real life example. We use all those with the help of these. By using these equations, we can find the distance traveled by the car. Brakes applied, car traveled 10 meters. Find the time taken to travel that distance. Time taken to come to rest. We use equations of motion. So this way, these equations of motion in our daily life, we apply to find the speed of the objects, velocity of the object. Okay, time taken to come to rest, distance traveled by the object before come to rest. All these, right? Please note down and practice these kind of problems. Here we have another example problem, example 3 problem. This is example 3 problem from the textbook. Okay, so you people will confuse because the words are not in the order. Question is not framed according to the grammatical rules, so you may have confusion. I make it easy for you. So there are signal lights. Imagine these are the signal lights. Okay, these are the signal lights. A locomotive means vehicle. It's a vehicle. Okay, so which is the distance between the signal light and this locomotive is 400 meters. When you are looking at this locomotive, this is moving with the initial velocity u, 54 kilometers per hour. Okay, as it is traveling towards signal light, so brakes are applied so that it come to rest. after 1 minute. So the final velocity of the locomotive is 0. It is stopped before reaching the signal light. So before signal lights it is stopped. Now we have to calculate the distance between this locomotive and the signal light. Okay, this distance should be calculated. Okay, so this is our question mark. You know what is this distance? Total 400 meters. If we know this distance can be calculated easily. So now we are going to find this distance. So object is moving with what velocity? Initial velocity u. Initial velocity u. 54 kilometer per hour. But kilometer per hour is a practical unit. We have to convert into meter per second. So 54 into 5 by 18. 18 ones, 18 threes. 3 5s are 15 meter per second. Okay. Next. Final velocity will be 0. What is given? Final velocity is 0. We have initial velocity, final velocity, and the retardation also given. Due to the application of brakes, the speed of the vehicle decreases. Whenever speed decreases, it is called velocity decreases, it is called deceleration. Okay, so the deceleration also given, a value minus 0.3 meter per second square. Why it should be taken negative? Because it is negative acceleration. That is why it should be taken negative. Now we have to calculate the distance traveled before come to rest. Distance traveled before come to rest. S should be calculated. To calculate the S, we have two formulas. In the previous problem we have done. One is S is equal to ut plus at square by 2. The other one is v square minus u square is equal to s. Here we have s, here also we have s. But to find distance using this second equation of motion, time compulsory. Okay, so without time we can use this equation of motion. Now we are going to use this equation of motion s, because we have v value, u value, okay, v value, acceleration, nothing but deceleration, then s. So related to this we will do the problem. Now S is equal to that formula. S is equal to v square minus u square. S is equal to v square minus u square by 2a, because I am taking this 2a from RHS to LHS. Next, substitute the values. S is equal to v value 0 minus u value 15 square. 15 15s are 225. So direct I am writing 225 by 2a, 2 into minus 0.3. Okay. Next, S is equal to 0 square is 0 minus 225 by 2 into 0.3. 2 into 0.3 is 0.6. Okay. 2 into 0.3 0.6. Minus 0.6, but minus get cancelled. So this can be written as S is equal to 225 by 6 by 10. 0.6 can be written as 6 by 10. In the next step, that can be written as 225 into 10 by 6. S is equal to 3 2s, 2 3s, 2 5s. Okay. So now this is 225 into 5 divided by 3. 200 into 5,000, 25 into 5, 125, 1125 by 3. Now we have to do 1125 divided by 3. 3 3s are 9, 2 is left over, take the 2 down, 3 7s are 21, take the 5 down, 3 5s are 15. So 375 meters. So what is the distance traveled by this locomotive after the brakes application? 375 meters. Okay, what is the distance traveled? 375 meters. So this distance is equal to 375 meters. Before it come to rest, it traveled 375 meters. What is the total distance between the initial position of the vehicle and this signal light? 400 meters. It is stopped after 375 meters. Then what is the distance between this locomotive and signal light? Total 400 minus this 75. So S is equal to total distance minus distance traveled by the object. So 400 minus 375, then that is equal to 25 meters. So now this vehicle come to rest, okay, just before 25 meters of the signal light. Okay, so if you read this question, it creates lot of confusion. So this is the easy way to understand the problem. Okay, please note down this problem.